This video shows how to perform physical modifications to the 8 Dynamixel AX-12A actuators used in the robot. For this process, you'll need your Dynamixel AX-12A actuators, 3D printed jig parts, including the hole template with 4 M2 threaded inserts, the motor plug, and the spanning cap. Additionally, you'll need 2 pieces of masking tape, roughly 16 millimeters in diameter, 4 M2 30 millimeter screws, 2 sealable plastic bags, and 1 electrostatic safe sealable bag. You'll also need microfiber cloth, smaller microfiber cloth, something to protect your workspace from grease. You can use a piece of paper or cardstock. You'll need some disposable nitrile gloves, 99.9% isopropyl alcohol, a flashlight, drill bits in 1.5 millimeter diameter and 2.5 millimeter diameter, regular pointed tweezers, blunt edge tweezers, Phillips 0 or 00 screwdriver or M2 screws, some smaller round files, utility knife, either a drill press or just a standard power tool drill, a vise that allows you to securely hold the actuator while you drill into it, and for safety you'll need eye protection, safety glasses, and an N95 respirator. So now I'll arrange these things and we will get started. So to get started, we're going to start with a regular AX-12A actuator out of the box, and we'll convert it into one that has openings for better thermal regulation. So the first thing I'm going to do is I'm going to go ahead and put on my nitrile gloves, because the actuators do have grease in the gearbox. To help protect my workspace, I'm going to just take a piece of cardstock paper and put it over the surface here. The first thing that we're going to do is on the actuator, on the bottom, there is typically a quality control sticker. And since we're going to drill through this surface, we need to remove that sticker. So I'm going to just take some blunt tweezers and just peel that sticker up. Go ahead and grab it, pull it right off. And you can dispose of the sticker. And then we just want to clean up this surface a little bit. So I'm going to take a microfiber cloth, get some isopropyl alcohol, and I'm just going to apply a little bit to my cloth. And then I'm going to use my microfiber cloth just to wipe away any residue that might be on the motor, on the outside of the actuator. And we can go ahead and wipe down the other sides of the actuator, just clean the outside casing up. Again, usually from the factory, the casing is fairly clean. Sometimes you'll see a little bit of grease that's leaked out of the seams, but just wipe it away. So now I'm going to place the actuator on my work surface with the back side where the wires connect down, so it's just facing upwards. Make sure the motor is in the home position, which we put it in when we tested it. Just double check that the line at the top, that the notch is aligned. And now what we're going to do is open the front section of the Dynamixel actuator. So the actuator is split into three main parts: the front casing, the back casing, and then the middle section, which holds all of the components in. So we're going to take the front casing off as a first step. So what we need to do in order to do that is to take our Phillips screwdriver, and the first thing we're going to remove is this screw that holds the servo horn on. And so I'm going to apply a little bit of pressure to the servo horn as I unscrew it so that it doesn't rotate, so that just the screw comes out. And then I'll remove that screw, and I'm just going to set that aside for right now. Now, I want to actually remove the servo horn itself, this plastic disc that rotates on the output axle of the actuator. And so to do that, we're going to pull it off. So it sits on a serrated axle, so it's got little ridges in it, and you can just lift it off. Now, you can try to just do this by wiggling back and forth. That may be a little bit difficult. So if you'll just take a blunt instrument and kind of just slide it in this little gap here and give a little bit of upward pressure, you'll see that it lifts away a little bit. And once it's lifted some, you can grab it and just pull it right off. And so then we have the servo horn separated from the actuator. So I'm going to set that aside as well. So next, we're going to remove the 4 screws that hold the actuator assembly together. They go all the way through the actuator from the front case, and they thread into the back case. And so they don't thread the whole way, just at the back. So we'll take our Phillips screwdriver, and we're going to unscrew each of the 4 screws. So you can tell when they're loose, you'll feel it. Okay, so now that they're all unscrewed, I'm just going to lift them out. I'm going to set them aside with the rest of our items that we've removed. You'll notice that they're threaded just on the ends here. So now we're going to lift away this front casing and expose the gearbox. So when we do that, I'm going to first of all make sure that we keep the actuator held down to the surface. Remember, these 3 parts are only held together by these screws, so now they're free to come apart. I'm going to also apply pressure to this serrated axle that we took the horn off of, because it could come up with the front casing if I don't. So I'm going to hold onto that axle, hold onto this casing, and then I'm going to just go around the edges of this front case, and I'm going to kind of pull, and you'll see that it pops up pretty freely. Sometimes it's snapped in a little bit stronger, but I just kind of wiggle it, and I'm going to pull it straight up. And I'm going to rotate it, and you can see inside, you can see the grease, and you can see in most cases this gear number 1, will transfer with the front case. Sometimes it will stay in the gearbox. Either way is fine. And so now we can see inside of the gearbox of the actuator. So what we're going to do is we're going to remove these 2 screws that hold the DC motor in place, because we're going to need to remove the DC motor. So I'm going to take my Phillips screwdriver, and I'm going to remove each of these screws. Now, I'm going to be careful to wipe my tools down each time I use them in the side of the motor that has the grease in it. so that I don't cross-contaminate the other side of the actuator with the grease from the gearbox. Now I'm going to take one of my plastic bags and I'm going to use it exclusively for these two little screws because they are screws that have grease on them. So go ahead and pull the first one out, put it in this bag. Grab the second one, trying to get as little grease as possible, and drop it in the bag. And we'll go ahead and seal this bag up and just set it aside for now. We'll need it when we reassemble this. And I'm going to just wipe my tweezers down to get any grease off of them that transferred. Okay. So now we're going to carefully put the front casing back onto the motor, and we're just going to orient it directly above, come straight down, gently let it ease into place. The gear that's on the front side needs to mesh in with the others, so you want to be very gentle with it. Just kind of give it a little rock back and forth, and then you can click it, push it into place. You'll feel it snap, and you'll see that the seam is nice and tight here. Okay, so now remember that these casings can still come apart. We're going to flip the actuator over, and we're going to remove this back casing. So you just wiggle it. It should come off pretty easily. I'm going to set it aside with these other parts. And this will expose our DC motor, the backside of it, and the PCB that drives the actuator. So what we're going to do first is we're going to need to take out both this PCB and the actuator, and they're connected as a single assembly. And there's one screw right here, small Phillips screw, that holds the PCB to the enclosure. So I'm going to remove that screw. I'm going to set it aside with my other parts. And at this point, I'm going to take these parts and I'm going to take a separate resealable bag, and I'm going to put all of them into it. None of these parts have any grease from the gearbox on them, so we'll store them all together in this bag while we complete our modification process. Including this very tiny screw. There we go. Okay, seal that up and just set it aside for now. So now we're going to remove this motor and PCB, and one of the easiest ways to do this is to kind of begin to wiggle the motor where its two leads are attached. You want to do this very gently. And if you don't get any movement there initially, you can move to these connectors. These are pretty firmly attached, and you kind of come from the side here. So you'll see if you pull from the side, this PCB starts to wiggle up. So I'm just going to go with that, and it's going to come just straight out. So you can see the PCB will start to wiggle out. And in this case, you can see the PCB has come out and it's attached to the actuator with wires. So I can rotate it out. I want to be careful not to apply too much force to these wires. I just kind of want to give the motor a little shake until it pops out as well. And so once the motor comes through, we have this assembly that looks like this. It's the motor and the electronics that drive it. So we're going to take this and I'm going to put it in an electrostatic safe bag because of the PCB. I'm going to seal that up. And again, we're just going to set that aside for now. Now we'll take a look at the back casing of the motor. Remember, the front is still free to move without screws, so always hold it in place. And looking in the back, we see where the DC motor came from. You can see that there are 2 holes for the screws and a hole for the actual motor output to go through. And then up at the top, you can see that there's a axle that comes through that connects to a potentiometer on the PCB. So what we want to do is we want to seal up both of these holes that connect to the gearbox so that when we make our modifications, none of the debris moves into the gearbox. So to do that, what I first want to do is I want to look at each of these and see if there's any grease that's seeped through from the other side from the gearbox. And you can see in this case there is some grease that's coming through in this top axle. The bottom is pretty clean. So I just want to soak up what I can of that grease because I'm going to cover these with that masking tape, and the adhesive will work better if the surface isn't covered in grease. So I'm going to take just a little piece of microfiber cloth and I'm going to grasp it with some tweezers. And I'm going to start at the top, and I'm just going to start by dabbing down onto the surface, just trying to soak up the excess grease that's leaked to this side. And I'm going to kind of start to wipe around here just until I get most of it. I'm going to just reverse this microfiber cloth. And the top is looking pretty good. I'm going to just wipe the bottom surface where the motor comes through, just to ensure that it's nice and clean down there. And I'll give the top one final cleaning. And then I'm just going to dispose of this little piece of microfiber cloth. And since these tweezers are going to be used on both sides, I will make sure I wipe them down just to get any grease that may have transferred off of them. Okay. Now we're going to seal both of these areas using our masking tape. So I've got a 16 millimeter diameter circle of masking tape here. And I'm going to peel it up. And I'll just use these tweezers to do that. And then I'm going to take it and I want to just center it roughly on this axle. I'm just going to lightly touch so that it sticks to the axle in the center. And then I'm going to start to push the edges down around it just very gently. I don't want to apply any stress to the axle itself. I'm going to take these blunt tweezers and I'm just going to kind of work around the edges to try to get this tape to stick down into place. And you can see there's going to be some wrinkles in it. That's fine. I really just want to get a good seal all the way around. Just on the edges. So that seal is pretty good. Okay, now I'm going to take the other piece of masking tape, and then I will take it, lower it down roughly center. And I'm going to get my blunt edge tweezers and seal it down over these holes. Okay, so now I've got both areas sealed with tape. Now I'm going to take the motor plug 3D printed piece, and I'm going to use my tweezers to place it where the DC motor previously was, and I'm going to push it down firmly into place, and it is a very snug fit, so I want to make sure it's all the way in. Next, I'm going to take my 3D printed spanning cap piece, and I'm going to put it so that this point is going upwards, and it fits over right around these plastic tabs, and this part of it that has an open area allows the axle to come up into it. So I'm just going to push that into place, and you can see that it fits nicely and that it sits all the way down. And make sure it's fully in place. Okay, and finally, now that we have both of these in place, we're going to take our hole stencil piece and align it on the actuator, and we're going to start to lower it down. We're going to have this block, this square section goes down where the motor, the DC motor was, and it is an exact fit. So we want to bring it straight down all at once, slowly at first. And then we're going to start to push to make sure we get it around the edges. So it needs to go around all of these edges. Start to apply a little bit of force, just kind of sandwiching it on. You'll hear that click. It's come down on that side. It's come down on this side. And you can see that it is in fact all the way secured, because the edges are flat with the front casing, which, remember, the front casing can still come off, so be sure to hold that on while we do this. And we can look in here and we can see that all of the edges have been captured. So now we're going to flip the actuator around so that the front part is facing upwards. And we're going to take our 4 30mm M2 screws, and we're going to insert them into the 4 holes that we took the actuator screws out of, so that they pass all the way through the front plate, through the middle section of the actuator, and then they're going to fasten into the threaded inserts in our hole template. So we'll take our Phillips screwdriver, and we're going to progressively just tighten these up. So do it about halfway on that one, bring this one halfway in, and once they're threaded most of the way in, I'm going to go ahead and pick this actuator up because they're going to come a little bit past this surface. They're going to protrude out a little bit. So I'm going to hold the actuator while I finish tightening each of the screws down. And we can see that they're poking out just a little bit on this, over this edge. And so we'll take a look, make sure they're all about even, and that everything is tight without applying too much force. All right, so that looks pretty good. So now this front plate is attached to our hole stencil and has captured this middle portion. So now we are ready to begin drilling these holes into the sides of the actuator. So before we start drilling into the actuator, make sure that you have your safety glasses and respiratory protection as well. And be sure to follow all of your local safety guidance. I'm going to remove this piece of paper that's protecting my workspace. And I'm going to bring in a vise that's going to hold the actuator while I drill into it. I'm also going to take a piece of microfiber cloth that's big enough to cover this front area. And I'm just going to use that when we put this up against this vise so that I don't scratch the exterior casing when I clamp down on it. So what we're going to do is I'll start with this side, and we can start with any side. I'm going to put this into the vise and make sure that we watch out for this little axle here with this notch that protrudes. So I'm just going to load it in where that is able to stick out. Just tighten my vise up just enough so that this workpiece doesn't go anywhere while I'm drilling into it, in case the drill bit snags in the plastic or anything like that. Okay, so it's in there nice and firm. And we're going to start drilling on this surface. So I'm just using a battery-powered drill. You can use a drill press for better control. I'm going to start using a 1.5 millimeter drill bit, and I'm going to drill pilot holes into each hole on all three sides, and then we'll come back with a 2.5 millimeter bit and finish out those holes. The main reason is that that clears out some of the material and it makes it a little bit easier to do the larger hole drilling process. And since we don't have to stay in contact as long or spin as fast, the plastic tends not to melt or chip away using this method. If you have a controlled drill press or a CNC, you don't need to worry about the pilot holes, but we'll do it since we're just using a basic hand drill. So I will put my safety glasses on, respiratory protection, and I'm just going to center my drill bit, and I'm going to apply just a little bit of pressure. And you can see, I know I've gone through because I can see this white plastic, which is the 3D printed backstop that is catching me. So it's not very far. It's about 1 to 2 millimeters of plastic that we're drilling through. So we can do this without needing to spend too long drilling into each hole. And you can feel this, the drill bit will drop down just a little bit when it punctures through. I'm also just using my fingers to pull away this material from the drill bit. That's because this drill bit is not spinning enough to get hot or anything that's dangerous, and I need to just kind of clear that out of the way. It makes it a lot easier for me when I'm drilling these holes. So I'll continue doing that. All right, let's take a look and see if we got them all. Looks like they are all good. And we can see all the way through to the plastic backing. Okay. So now I'm going to loosen this vise up, and let's go ahead and do the other side. Just going to verify that we've drilled through everything, and it looks like we have. Just going to dust this off a little bit, and we'll take the actuator and do the top portion. It does look like we have drilled through all of them. So what I'm going to do, I'm just going to clean up this workspace a little bit. Now I'm going to take the drill. I'm going to swap from the 1.5 millimeter diameter drill bit over to the 2.5 millimeter. Okay, so now we're going to go back over all of the holes using the 2.5 millimeter bit. Okay, so we will remove the actuator from the vise. Just going to kind of look at all of my holes again. Looks pretty good. I'm going to dispose of the microfiber cloth. And I'm going to clean up my workspace. I'm just going to vacuum up a little bit. I'm going to bring back this piece of paper just to place on my workspace. And we're going to take a look at the holes that we've put into the actuator. So the first thing we're going to do is we're going to take off this hole template, but we're going to keep the spanning cap and the motor plug on the actuator. So we'll flip the actuator where it's facing upwards, take our Phillips screwdriver, and we're going to unscrew each of these 30 millimeter M2 screws that's holding the front of the actuator, well, holding all of the actuator to the hole template. And so remember when we take these out that this front plate won't be held in with anything. So we need to be careful. Just take each of the screws out. Set them aside. Now I'm going to pick up the actuator and I'm going to hold the front case on. I want to keep the spanning cap in place, but I want to remove this hole stencil. So I'm going to apply pressure on the front case to keep it on. I'm going to apply opposing pressure on the spanning cap, and then I'm going to push upwards on the hole template until it kind of rocks free. And so you can see that it's starting to do that. So it'll just lift out. There we go. We'll just set it aside. And you can see that we've got our actuator with the newly made vents in it. But we've still got debris in here, and so our next step is to clean out this debris. So first I'm just going to take a cloth and wipe away what I can, just a microfiber cloth, just to kind of grab any little particles that are easy to get to cling to the cloth. Now I'm going to keep these covers in place. I'm going to use the vacuum to see what kind of, if I can get a lot of this out. I'm going to hold on to the spanning cap while I do that because my vacuum is pretty powerful. The motor plug will stay in place, so I don't need to hold it. And so I'm actually going to take my piece of paper and just move it to the side for a moment while I do this. So that's removed a lot of that debris. Take a look with some light. There's not too much left in there. Really hard to see, actually. All right. So next, I am going to take a little compressed air. I'm going to again hold on to the spanning cap. I'm just going to do some bursts of compressed air through each side of the actuator, and a little bit around the edges. Again, I'm just trying to loosen up any little particles that are in there because I don't want them to transfer over to the gearbox. So now that I've done that, I'm going to do one more cycle of vacuuming. So next, I'm just going to take a round file and I'm going to use it just to go into each of these holes and just turn just a little bit, just to take off any rough edges that might exist. And if you see any little edges that are more substantial, you can use a utility knife or a different file to work to remove them. All right, so now we've got a little more dirt and debris here. I'm going to use a little compressed air. So now we will go ahead and remove the spanning cap and the motor plug. So for the spanning cap, I'm just going to use my hands, just lift it straight out. set it aside. You can reuse it. And we can see there's no debris under there. Tape seal is still in place. I'm going to use some blunt edge tweezers to grab onto the motor plug, rotate it, pull it out, set it aside. We can use it again later. And everything looks good in there as well. So I'm going to run my vacuum over this one more time just in case there's any particles, and then we will remove the tape. All right, so now I'm just going to take my tweezers, going to remove this top masking tape. Yeah, I can just dispose of that. And then I'm going to take my tweezers and remove the bottom masking tape as well. I'm going to make sure you get all of the tape out, so if it tears, you get all of the pieces. So now we've removed all of the tape. I'm going to go ahead and restore my paper work surface here. And we'll go ahead and get the electronics in the DC motor inserted back into the actuator. So I'll retrieve that from the electrostatic bag. And so we'll slide it back in exactly the way it came out. Remember that the front panel is not fastened in place, so we do need to hold on to it while we do this. I'll just align this motor in the PCB, and then I'm going to push them down and make sure they sit flat in place as they were previously. Okay. Now, I'll go ahead and get items out of my resealable bag, the non-greasy items. So we have those. There's screws. And the first thing that we need is this tiny, tiny little screw that holds the PCB in place. So I'll go ahead and grab that screw, and I'm going to reinsert it to fasten the PCB down to the enclosure. So I'll just tighten that in. Make sure it's fastened fully. And now this is restored to its original state. We will take the back casing. Just going to set it down and then push it into place. You'll hear it click. You can see everything fits as it did previously. So now we're going to go ahead and orient the actuator facing upwards so that we can reattach that DC motor, the screws that we removed from the gearbox. So we're going to do this the same way we removed the front casing previously. I'm going to hold down on this serrated axle, and I'm going to hold the body of the motor, or the actuator, down to the work surface. And I'm just going to pry the edges here, and then just pull this straight up, and flip it over and set it to the side. And you can see where we need to reinsert these two little screws that we have in a separate bag. So we'll go ahead and do that. Let's go ahead and retrieve these screws. This bag does have grease in it, so I'm gonna dispose of it. I'll take these screws, screwdriver, and I'm going to put them back into position here. Okay. I'll just tighten it just a little bit just to get it started. The second one in there. Go ahead and tighten it down all the way, and then I'll come back and tighten down the first one. So now we have both screws tightened back into place. I'm going to go ahead and just clean this screwdriver since it's got grease on it from this side. Okay. Now, what I'm going to do is we could just close this up like we did before, but because I want to be sure that the gears are meshing properly, I'm going to use my tweezers. I'm going to lift gear number 1 out and just set it here. And then I'm going to take this axle as well. And it's quite slippery. I'm going to move it over to this other side where it mates. And you may need to use blunt tweezers as well. Again, it's quite slippery. We're just going to insert it into this opening on the other side. Okay, so it just sits in there just barely. Okay. Then I'm going to take this gear, flip it like this, place it onto the axle, and lower it down so that it meshes with this gear. Now, if we've done this successfully, what we can do is we can lightly rotate this gear back and forth, and you will see that propagate through the chain of gears. And that's what we want. So now that we've done that, I'm going to wipe this grease off of my gloves. Now we can go ahead and put the front case back on. So we're just going to take it and lower it straight down and just gently bring it down. Then we'll apply force from both sides. You hear a snap when it snaps into place. Just make sure it's aligned. I'm going to wipe the grease from these tweezers since we're done using them in the greasy situation. Okay. And now we're going to reinsert our 4 screws that were originally in the actuator. So put them into each of the 4 corners. And then we'll go ahead and progressively tighten them down. Remember, they connect with the back panel. That's what they thread into. So just tighten each of them down about halfway to start with. And then we'll go ahead and bring them all the way. Tighten them fully. Okay. And then we can see that the motor is assembled and is fitting together as it was previously. So now we need to put the servo horn back into place. So we can align it. It has a little keyed slot on it that aligns with the little notch on this axle. So we will align it like that. We see the notch is aligned with the keyed area. Once we have it, we'll just push it into place snugly. And we can give it a little wiggle back and forth. And you can hear the gears moving, and you can feel them as well. We won't back drive it too much, but Just give it a little rock back and forth to make sure everything is still meshed together well, and make sure that we have this aligned still. And now the final step, we will put our screw back in place for the servo horn. Tighten it down. I'm going to hold on to the servo horn just a little bit so that it doesn't spin when I get it tight. Okay. And then I'm just going to make sure that I've got a little bit of play in this still. Yep, I can still rotate it a little bit. And so now this actuator is ready to go back to the test bench to ensure that it's still in good working order.